the first question on the back of your packet, page 8, says the density of a substance is 1.63 grams per milliliter, and then it asks what is the mass of 0.25 liters of the substance. So right away, we know no matter what we're doing, we are looking for what? Mass. So you can start off by saying M equals blank, and then we primarily are going to measure mass in grams, so that's a safe bet for your unit. So M equals blank grams. Since it says density, at this point, a lot of your minds are probably going to the density equation of D equals M over V. However, this section is talking about multi-step conversions, where instead of using that equation, we are actually going to use this as a conversion factor. So use as a conversion factor. So what that means is that if I have density equal to 1.63 grams per milliliter, that means that 1.63 grams is equivalent to how many milliliters? So based on that unit of grams per milliliter, grams per how many milliliters? So think about, I think when we first learned the unit for density, I talked about the comparison between like miles per hour. And in that, if it's miles per hour, and I say that I was going 35 miles per hour, I went 35 miles per how many hours? 1. So if there's not a number there, it's implied that it's 1. So if I talk about grams per milliliter, it's implied that it's 1 milliliter. So 1.63 grams per 1 milliliter. You see where I got that from? So you're going to need to pull that information out of that value to use it as a conversion factor. So if I have 1.63 grams, how many milliliters is that equivalent to? 1. So in this case, if we're using that as a conversion factor, the thing that I'm trying to actually convert is this many liters. So I'm going to start with my 0.25 liters. 0.25 liters, and then draw your line. So instead of using our density equation, we're going to do this as a long conversion. I have liters up here. I'm trying to convert it to grams. I'll scoot back out so we can keep seeing the whole thing. And then automatically, even if you don't fully understand where you're going next, can you tell me your next step? Disco, perfect. Okay, so I'm going to bring just my unit, not the number, but only the unit of liters down to the bottom. So in this example, I'm starting with liters. I brought liters down to the bottom so that it cancels because I know I don't want to end in liters. I want to end in grams. And the only other information that I have is this conversion factor of grams per milliliter. It's not grams per liter, it's grams per milliliter, so I think a good next step is converting liters into milliliters. So the question that I've been asking this whole time is which one is bigger, liters or milliliters? Liters is bigger, so I'll put a 1 next to it, and how many milliliters are in 1 liter? I think I'm hearing whispers of it. 1,000. Okay, so 1,000 milliliters per liter. I don't want to end in milliliters, so I'm going to disco down that unit. And I'm trying to get to grams, and thankfully I already outlined that I'm going to use this as a conversion factor. I know that 1 milliliter of this substance, whatever it is equivalent to that many grams of that substance. So 1 milliliter equals 1.63 grams. So this is the first time we're using density as a conversion factor instead of plugging it into the equation like we normally would. Now you could still solve it using that equation, but you would have to convert this first. So since we're already converting, it's easy to just add this in as a next step. So my liters will cancel with liters, my milliliters will cancel with milliliters, and I'm left with grams, which is what I want to end in. So as long as I have all my numbers plugged in, then I can just go ahead and calculate this. So if I plug it into my calculator, I have 0.25. Remember, every time you cross a vertical line, you're going to multiply on top and divide on bottom. So 0.25 times 1,000 times 1.63. And then technically you would divide by 1 and divide by 1. But again, we know that doesn't change our answer. So when you calculate this, I get 407.5. I'm going to write it off to the side. Because that's not my final answer, even though that is what the calculator gave me, I still need to do what before I make it final? Perfect. Pick the right number of significant figures. And so when we're doing any conversions, remember our significant figures need to match our given information. So in this case, remember this is our given. My given has a 0 at the front. If you look at the board, I still have the reminders up there. Are leading zeros ever significant? No. So even though there's a decimal in the number, this 0 is not significant. Any non-zero digits are always significant. So this number of 0.25 has 2 significant figures, which means that my final answer needs to also have 2 significant figures. So if I round this to 2 significant figures, I'm going to look at those first 2 digits. If I just write 40 and then turn the last things into a 0, it's not going to be 2 sig figs, but that's good for me because that 7 actually rounds the 0 up. So it would be 410 as my final answer, and that answer has 2 significant figures and is just a rounded version of this number. So even though there were decimal places in my calculator answer, I can drop those decimals because my answer has 2 sig figs.